All right, I'm back. In this section, I wanted to look at some building blocks of geometry. Um, and we're kind of, geometry is foundational. In other words, you start with something very simple and then you build upon that to make more complex things or understand things in more complex ways. So here I've got, it looks like a little birthday cake, but the idea is at the bottom of the foundation, you have points, lines, and planes. These are undefined terms that are the basis of geometry. Everything we do is based on a point, a line, and a plane. And then from there, we can make up some definitions. For example, one definition might be a circle. A circle is a point that's the same distance to a group of points that's the same distance to one point. And you can kind of picture that in your mind. Another definition would be an angle, which is two rays, which is two parts of a line that meet together at a vertex. So definitions follow from point, line, and plane, and then we have properties. We've talked a lot about the algebraic properties already. And then we have postulates, which are sometimes they're called axioms, but they are common sense rules that you can just kind of look at and recognize that they are that they make sense and they're geometric in nature. And then finally, with all of those things, we can put them together in different ways to come up with new and interesting concepts or relationships that we call theorems. And theorems need proof. They need to be. We need to use all these other things in a truthful and sequential way to show that the theorems actually work. So I want to kind of walk you through this process, and I'm going to start with something like this. I've got a line, and so here we have the basic idea, and then I've got another array, which is part of a line there that intersects that line. And so this is kind of where we're starting. You can kind of see two angles there. And here's a definition for you. If you had an angle that looked like that, and then one that looked like this, and maybe this is 100 degrees, and this is 80 degrees, a definition would be when two angles add up to 180, they are called supplements. So these are supplementary angles. Okay. So we're talking about angles which are based on points, lines, and planes. And then we're talking about special kind of angles. We're kind of defining supplementary angles. So let's take a look at a postulate involving supplementary angles. This is sometimes it's called the protractor postulate, but it comes back to this original picture here. The most accurate way to describe it is as a linear pair postulate. And you can tell just by looking at this that these two angles, if this was angle A and that was angle B, angle A and angle B would add up to 180 because by using a protractor, you know that a line has 180 degrees. We measure the angle on a protractor just as this line moves. You get so much on this side and so much on that side, they always add up to 180. So it's called the linear pair postulate. Look at this postulate and there's one other idea I need to show you, and then we're going to come up with a theorem. So here are a couple of angles. Here's angle A and angle B. And you have this angle that's the whole thing. Well, angle A plus angle B would equal the measure of angle C. So that's kind of important to know. And this is called the angle addition postulate. Kind of makes sense. So there's angle A, angle B, and then the whole thing is angle C. So angle A plus angle B, the measure of angle A plus the measure of angle B would equal the measure of angle C. M stands for measure of. Okay. So we have the angle addition postulate, we have the linear pair postulate, we know something about supplementary angles. This is all kind of based on point lines and planes. this is what we're going to do now. We're going to kind of prove, we call this angle A, and that angle B, and we're going to prove that angle A and angle B have the same measure. They're congruent angles. When angles have the same measure, they're congruent angles. So in our proof, we're going to organize our information this way. We'll put angle C right there. So prove angle A plus angle B. Oh, I'm sorry. Prove angle A is congruent to angle B. That little symbol means that they're the same measure. They're congruent to each other. So we have some statements here and some reasons here for the statements that we've made. So first statement, I'm going to say angle A plus angle C equals 180. And the reason for that is you can tell that they make a line, so we're going to put linear pair postulate. And I can also write angle B plus angle C equals 180. And again, the reason for that is that it's a linear pair. Okay. Now this, I'm going to introduce a new property here. Angle A plus angle C equals 180, so this much equals 180 here, and then this much equals 180 there. And I'm gonna, since they both equal 180, can I set them equal to each other? So angle A plus angle C equals angle B plus angle C, since they both equal 180. And the property that we're dealing with is called substitution. Because we just substituted in place of 180, we kind of just put in angle B plus C right up there in place of 180 because it's equal to 180. Okay, we're almost there. We were trying to prove that angle A equals angle B. We have angle A here, we have angle B there, but we have angle C on both sides. So what can we do with angle C to get rid of it? If you said subtract, you're right. So angle A is now congruent to angle B because we subtracted angle C from both sides. So subtraction. And I'm going to put property of equality. We did it from both sides there. So what we have is a proof that angle A, this angle here, equals angle B. These are called vertical angles, by the way. We have a proof of the vertical angles theorem. We used postulates, the linear pair postulate. We used some properties, substitution and subtraction property of equality. And to build up to this point, we had to understand some definitions and some basic undefined terms. So we use this stuff to kind of get up here to a more complex idea. So angle A equals angle B, that's our we've proven that will always work. Whenever you have two lines that intersect, if it's x and y there, x is going to equal y, and A would equal B there, and so on. Now, from here, we could use this theorem, the vertical angles theorem, to prove more theorems, and we're not going to go that far this time, but in the future, you will use vertical angles to prove even more theorems and other things. So that's kind of how this works. I hope this was a little bit helpful to you. I know that you're starting to have a lot of properties and postulates, definitions. There are a whole bunch of them. Please refer to the list that I'm going to make so that you can kind of review them. And thank you. Have a good day.